So we're supposed to prove, or sorry, we're supposed to select all the proof outlines that can be used to prove this statement, which is for all integers x, if p of x is true, then q of x is true. Okay, so let's look at the first option. Let x be an arbitrary integer. So this is good. We want x to be arbitrary because we want to prove that this is true for all integers, right? So we want to make sure that x is generalizable. And then we assume p of x is true, and after a couple of steps, we show that q of x is true. Okay, so this would be correct because this is essentially direct proof, which is a valid proof outline to prove any statement. Then let's look at the second option. So x is an arbitrary integer again. You assume p of x is true and q of x is true. Okay, so if you assume that both p of x is true and q of x is true, then automatically, no matter what, p of x implies q of x is gonna be true because you have a true implies true. So that's always gonna be equal to true. So this leads to circular reasoning. Um, yeah, so this is not gonna, this wouldn't work. Okay, so let's look at the next statement. Let x be an arbitrary integer and assume that q of x is false. And then after a couple of steps, you show that p of x is false. So what this does is you assume not q of x and therefore prove not p of x. And this statement is the contrapositive of p of x implies q of x, which is the original statement. So yeah, this is a good this would be a correct proof outline to prove the given statement. Okay, so then we have suppose for contradiction that there is an integer x such that p of x is true but q of x is false. And then you conclude by saying that you've reached a contradiction, so that proposition is true. So what they've done is they say assume there exists x, p of x, and not q of x. And this is exactly the negation of the statement we need to prove, which is for all x, p of x implies q of x. So what they've done is they have assumed the negation of the statement they want to prove, and then they get a contradiction. And so this is essentially proof by contradiction. So this would be a correct proof technique. Okay. So D is good. With E, what we do is we assume P of X is false and then conclude that Q of X is false. This is not equivalent to P of X implies Q of X. So this would not prove the statement.